Okay, so the one part of your unknown determination is determining the functional group class that your unknown is in. And the way this works is you would have a test tube with a small amount of water there, and if you put a couple drops of your unknown in there, you would determine whether that was soluble or insoluble. And moving, if your solid sample's insoluble, you'll just see it, the solid settling to the bottom of the tube. If it was a liquid unknown, you would see two different layers there where it just wasn't mixing. So then you would move on to the next step with the 5% sodium hydroxide, and continue on the same way, just determining soluble or insoluble. And if you continue those steps using the different solvent for each step, you'll be able to narrow it down eventually either to one functional group or, for example, here, where you narrowed it down to several different functional groups. So that at least gets you started where you can look to your IR and NMR spectra, melting point, etc., to narrow it down to a specific compound. Okay, so I'm going to do an example here with 2-naphthol and we're going to run through the solubility class test. So the first step has you testing solubility in distilled water first. So I've got a ml of distilled water, and this one is a solid sample, and then I'm just kind of agitating it, mixing it, trying to get it to dissolve, and you can see that it is not going to happen. So it's just settling to the bottom insoluble. So first test done. So then you can just insoluble, move on to your next step. So now I'm grabbing a fresh test tube, and I'm putting about a ml in there. And now I'm trying the same thing, throwing a few crystals in there. And trying to get that to dissolve. And this one was kind of slow to dissolve, but it does dissolve in sodium hydroxide. So that's a positive test with sodium hydroxide. So we mark that as soluble and move on to the sodium bicarbonate. And as you can see, we are not getting a soluble result on that. It's not even attempting to dissolve. So we will call that insoluble. And if we follow this on our list, we were insoluble and then soluble in the sodium hydroxide and then insoluble in sodium bicarbonate, and that gives you the result of a weak acid, narrowing it down to a phenolic compound. And we already know that since I told you on this sample that it's 2-naphthol and naphthol is a phenol. So that's narrowed you down to one functional group. Okay, and after doing the solubility test, you would be taking an IR of the sample and just picking out anything that either told you functional groups that you didn't know, or confirming functional groups that you already suspected, like with where we already had this narrowed down to a phenol. If you look at your IR interpretation tables, you'll see that in this range, this 3300-ish range, this broad stretch signal here would indicate a OH stretch. So that kind of confirms your suspicion that you have a phenol. Okay, so after looking at your solubility test and narrowing it down to phenol, and your IR telling you that you had, confirming that you have a OH stretch in your IR, next you could look at your IR or your Proton Nmr, and using your NMR tables, you would see that these are all aromatics, and integrating all to a total of 7. You got 2, 1, 1, 1, 1, 1, and you already know you have an OH, and that is way down here around 5, and that's a 1H signal, so that makes sense. Okay, so from the proton, if none of the protons were equivalent, you had 7 aromatic protons and then 1 from the proton from the alcohol. Now looking at the carbon NMR, you count 3, 4, 5, 6, 7, 8, 9, 10 signals. If none of those are equivalent carbons, then you've got 10 carbons in your structure. So that, and all of these signals fall as on the table as aromatic carbons. So far, we're pretty sure we have 7 aromatic protons and 1 proton from an alcohol. Our solubility class says we have a phenol, and our carbon NMR suggests 10 carbons if there aren't any equivalent carbons. So we at least, we're pretty sure it's in that ballpark at least. So we will go to experiment 9 and look at the unknown listings by compound class. And you'll find phenols. There are phenols. And it takes you to this PDF. And let's assume you took a melting point of this compound and you found 119 to 121 degrees. If you look at the PDF, it starts out with liquid samples, so you would scroll past the liquids until you found the beginning of the solids, and you would look on the list. It starts at the lowest melting point, and you would just find find ones that are in the ballpark of that 119 to 121. So if you err on the side of caution, you'll look at things that are plus or minus 5 or 10 degrees, and then you would, if you've got it narrowed down to, let's say, all of the compounds that are in 115 to 125, you would just have to try to deduce with your spectra which ones would make sense given the spectra that you have and the signals that you would expect to see here. I can tell you that none of you have any nitro compounds, so you can rule that out. You can cross out any of the nitro compounds. And aside from that, you have to use what you've learned so far from your spectra to choose a final answer for your unknown. And since in this example I told you that your answer was 2-naphthol, you'll see that 2-naphthol is at 123, and it does line up with, it does match up with the spectra, and it matches up with your melting point, and that's all you need to determine your